Welcome to today's session on Databricks and the Data Lakehouse. We're going to start by introducing Databricks briefly, and then we're going to move on to looking at specifically what do we mean by the Data Lakehouse. So today's session is going beyond just Databricks and looking at a little bit more of the some of the paradigm that they're trying to build towards with the Data Lakehouse. And if that becomes a more common term that's used, we'll take a look at what it means. From there, we'll step into looking at enterprise analytics with Databricks. So at that stage, taking a look at how Databricks matches the definition of the Lakehouse and specifically how you can use it in your organization. From there, we'll take a look at a couple of demos while we look at some of the more kind of detailed aspects of Databricks. So we'll show how it meets some of the targets with the Data Lakehouse, and then we'll talk about how to get started and try and touch on some of the kind of practical aspects of how you can start moving forward with building your own Data Lakehouse. Before we get into the detailed stuff, I'll start by doing a quick intro to Thurgood. So at Thurgood, we're a global technology agnostic consultancy. But we specialize in data engineering, data science, and data visualization. So a wide spectrum of activities within the data and AI space. And we have offices across a number of different locations. You can see those listed on the slide. So today I'm presenting from our Singapore office. We've also got offices based in London, Philadelphia, Boston, Sao Paulo, and Bangalore. And then some of the technology vendors we partner with. So I mentioned that we're technology agnostic, but these are the kind of best in breed technology vendors that we've got deep experience working with. Particularly, you'll note in the middle there at the top, we've got Databricks just as well for today's session. But also we'll mention Microsoft's Azure platform and AWS as two of the platforms that are supported by Databricks. And so we've highlighted those there as well because they're pretty relevant for today's session. So let's get started then, and I'll take you through just a quick introduction to Databricks, and from there we'll take a step through some more of the kind of the thinking and the theory behind what a data lakehouse is and why it's something that we should be interested in. So to start, Databricks, who created Spark. So Spark you may know as the Apache open source tool. It's heavily used for big data engineering and particularly kind of heavy analytics workloads on big data. So Databricks then have formed as a company and have kind of added bits into Spark. They've built on top of Spark to create an enterprise platform which provides a heavily optimized version of Spark. And they refer to that as the Unified Analytics Platform. And when they say Unified Analytics Platform, they mean it caters to basically two main use cases. One is data engineering, the other is data science. And that's all with using the same platform, the same Spark-based platform, using the same underlying data for both of those use cases. One of the key things they've done to that is they've updated Spark and they've made enhancements to Spark to make it run cloud-based on, at the minute, Azure and AWS are the two that are available. I'll comment a little bit later on what's happening with GCP at the minute. But they've updated it really to integrate it with those platforms, to use the native architecture from each of those platforms to build out a cloud-based, cloud-enhanced version of Spark. And in particular, one of the key things that gives you is an ability to auto-scale. So if you're familiar with cloud computing, one of the things you want to be able to do is use the resources only for the period of time that they're doing useful work. And if you've got a big data job that needs to run, you want to be able to run that quickly by using a lot of compute power in a short period of time and then turn it off at the end. Databricks handles a lot of that complexity for you. So you can have Spark that scales up to hundreds of machines and then right back down to even to zero if you want to turn it off, or to one or two machines if you want to keep it running and keep it accessible for smaller jobs. And it does all of that automatically. So it's a great platform for large-scale activities around both data engineering and data science. Another thing we'll see when we take a look at the tool is multi-language notebooks. And that's something that, again, supports those two use cases fantastically. So if you're writing in SQL, if you're used to writing SQL queries, you can write those in Databricks using Spark SQL, and it will run and everything in parallel and do it really quickly on large data sets without to rewrite all of your SQL code specifically to do that. And then the other language, so Scala, is kind of the native language for Spark and Databricks. So again, that will do everything fantastically at scale. With Python, you've got PySpark that you can use, or if you want to kind of use some of the more common Python libraries or Python packages, R libraries to do, for example, your machine learning based on what you're used to doing on other platforms. Those are available in the Databricks platform as well, so you can bring in code from those and run that on the same data set in the same place. And there are a couple of extra things you need to do to optimize that if you want to make it take full advantage of Spark, but it's really possible to take those languages and make them work better on kind of enterprise scale data sets to run quicker and give you kind of faster results on those using Databricks. So just to bring up the kind of, I'm going to highlight the kind of key things that you get with, I guess, first with Spark, but also the things that Databricks have built in specifically to the Databricks implementation on Azure and AWS. So the first thing to note, if you're doing data engineering, two key advantages. I'm going to make myself two here. One is that it's based on, like I said, the native components of Azure and AWS. So the logos there on the left are for Azure Data Lake and AWS S3. And for both of those, or in both cases, Databricks is using the storage from the native components in each of those cloud platforms. So you're really getting the advantage of storing the data in a cloud data lake with the Databricks platform on top of it. That kind of hints at some of the stuff that we're going to get into with the Data Lakehouse as well. And then Delta Lake is another component that Databricks built. It's another one that they've released to open source, but you can also get the Databricks within the cloud platforms. And we'll talk a lot more about Delta Lake later, but one of the key things it gives you is a lot more structure around your data and robustness and the reassurance that your data is going to be exactly what you expect it to be every time. So that's the key things that Databricks have done to make it a great tool for data engineering. On the data science side, I think my two favorite features. One is that it comes with a lot of the Python packages and R libraries pre-installed. So if you're used to setting up Python compute systems for your machine learning, you'll be aware that a lot of the time you spend considerable amounts of time installing these, getting them set up to run on the machine, and then you've got to make sure that they're running the same versions across the different platforms. With Databricks, each version of the Databricks runtime comes with a set list of these packages installed. So if you're running it and someone else is running it, so long as you're using the same Databricks runtime, you're only having to manage that one version, and all of these are installed for you when you start off. And then MLflow, again, Databricks, I love releasing stuff to open source. MLflow is an open source tracking tool that they've built for machine learning experiments, for deployments. You can track your different stages of the machine learning lifecycle. And again, there's a Databricks managed version of that. So when you set up Databricks on one of these cloud platforms, it comes with MLflow already installed and ready to run. But it's also possible to integrate that with a number of the other kind of machine learning tracking tools because of the way that Databricks have built it and open sourced it. So hopefully I've given a very brief introduction to Databricks, but it should have convinced you, I think, that there's a platform worth looking at. And so from there, I'm going to kind of step back into today's topic a bit and talk about what we mean when we talk about a data lakehouse. And this is a concept that Databricks really have pioneered, and it's one that's gaining traction beyond Databricks as well, from their perspective, and show why Databricks is such a great platform to use at the minute when you want to get the best of both worlds from the data warehouse and the data lake. So to start with, I'm going to highlight some of the features of the data warehouse. So maybe if you have a quick think before I move to the next slide, what are some of the things that you think about when you think about a data warehouse? And we're probably thinking things like reliability, structure, a large scale data store, so it's storing a lot of your organizational data from across different departments. A number of different concepts, but if you have a think about some of those things, but I've picked out kind of 5 key features that make this a really important concept that companies are keen to have. The core idea behind a data warehouse is that it's your organization's single source of truth for all the data that it contains. And that's an important property for the data that you're making decisions based on. If we're going to have a discussion about, say, the promotions we're running for a particular product, it's going to be a lot easier to have that discussion if everyone's talking about the same product, the same set of promotions, and we're analyzing the spend even in the same way on top of that. So single source of the truth is a key component of what we're looking at when we talk about data warehouses. On top of that, there are a number of technical capabilities that make them make them ideal for this kind of robust analysis of data. One of those is that the functions that are made available on data warehouses are ones that can be readily applied and readily relied on, so sometimes referred to as ACID transactions. And without getting into the detail of what that means from a technical perspective, it's all about giving confidence that even if something goes wrong during a load, we're still going to be looking at valid data throughout that process. Whether it's a load or getting rid of data or whatever you're doing, updating, you're always going to be looking at valid data. We're not getting kind of half loads or data discrepancies that are arising from things not being handled correctly in that. And then on top of that, we've got a more fixed data structure and format, and that encourages good governance in a way. So it's easy to keep the data in line. The sets of KPIs you're looking at are the same over time. If we're looking at a particular set of columns this month and building a report on it, that's going to stay the same next month, and we know that those reports are going to keep running because they're built on robust data. And then there are things that come with the benefits of a kind of tried and tested approach. It's something so they often make use of familiar query languages, very often based on things like SQL. So the widest group of analysts can make use of skills that they already have in those. And so it's easy to recruit talent in the local market who have some of those skills and can readily apply that coding. And similarly, most of the tools that there are available in the market for things like visualization, reporting, and business intelligence will support the kind of standard connectors for SQL-based data warehouses, and that makes them really useful for reliable reporting. You can always connect your reports to your data warehouse. And so that's what some of the things that have led to data warehouses growing in popularity, and most, if not all, enterprise companies will be using data warehouses for at least some of their data analysis. But then recently, there's been a shift towards data lake, and maybe kind of in the last, I don't know, 5 to 8 years, maybe more talk about data lakes, the talk growing, and more companies implement data lake approaches. So what do we think about when we think about data lakes? I'll give you a second to get those ideas in your head. Maybe we're talking about like flexibility. In some cases, people maybe think of that being a bit messy, and thinking about the lack of structure. Well, some of the key properties that have come about with the data lake, the key driver, I think, often is that companies are able to use cheaper storage approaches to store all manner of data, whether that data is structured or unstructured, even including things like scanned documents and telephone call recordings, with the ambition to analyze all of those to get a deeper insight into the various different patterns that there are, and hoping that understanding those patterns we can improve, whether it's improving our customer service, increasing operational efficiency, in some way driving benefits for the business. And you can see the attraction of a data lake approach. Because it's cheap to store large volumes of data, that really means there's encouragement to store everything. And then if we do that using open formats, we can share those same files, the same data across different technical platforms, and it's easy to connect that data with a wide variety of tools. And that goes for everything from large-scale data processing to really advanced analytics and statistical models that are built on the whole data set rather than a small sample even. So some of the more modern platforms, and Databricks is one example, and Spark that's based on, that could take really large volumes of data and process that in an efficient way. And moving from that then into things like deep learning approaches that really need to have all of the data available so that you're getting the good models that are built from some of those machine learning approaches. And then there's the ability to use some of those approaches that we're talking about on both semi-structured and unstructured data. So as I mentioned, things like images, scanned documents, even some of these platforms are getting into things like valuable real-time data, machine logs and sensor data that start to unlock more advanced analysis of things like predictive maintenance. If you're able to get a better understanding of your logs, can you understand what's going wrong and dig into that detail in a far more flexible, fluid way? And so there are a lot of use cases where the data lake approach gives us a big step up in features compared to what we've had with the data warehouse. And yet, potentially, we could say that we've lost some of those features that we saw as being really important in our data warehouse approach. And so particularly for thinking about the data sets where the majority of our decisions are based on typically a small number of the data sets, and those data sets become really valuable. So think about something like your finance data set, or if you've got a data warehouse that's tracking the movements of products through your supply chain, that could be another example. And for some of those really valuable data sets, some of the properties like having a single source of the truth, some of the properties like having reliability of automation and knowing that the data you're looking at is consistent, those can be those are really important and really valuable things. And on top of that, we need to make sure that our existing analysts are able to continue using the approaches that they're used to, at least, to do the valuable work that they're doing. And so that's where the Lakehouse vision kind of starts from, and that's where we're trying to get. In the Lakehouse approach, we're choosing those properties from the list, the properties of the data warehouse and the properties of the data lake that we want to keep in this new paradigm. And the reason we can do that is because the advantages of years as intentional software design decisions, with each software vendor aiming to have their platform be the fastest, most robust, most reliable way to store your data. The big driver for moving to more recently really happened with an explosion in available technology. So first in terms of cheaper commodity hardware, and then moving more recently to the cloud scale storage and compute options, and some of the efficiencies of the way that we can pay for those as we use them. On top of that, a more open ecosystem of analysis tools for unstructured and streaming data is developed over the top of the data lake and the cloud approaches. And all of that allows for that wider range of analysis. And so really what companies like Databricks are doing and what they're looking at with things like the Databricks with their Lakehouse vision is to take the technology and the growth in analysis tools that underpin those data lake advantages, all of the ability to store all of the data, structured, unstructured, the vast quantities of data, to run analysis on all of that, and then designing back in some of the valuable features that we've come to rely on with data warehouses. And so that means we could take advantage of the ability to process all manner of data sources, data types, the giant volumes of data, but rely on things like schema enforcement and transaction support to give us the data that's exactly right and exactly as we expect every time. And the approach also lays out a couple of principles here that help us keep maximum flexibility. So beyond just kind of technical approaches, we're also building in some principles into the Data Lakehouse vision. So things like we're committed to using open formats so that we allow other tools to connect to the data. And the reason for that is that we want to support a wider group of users across a wider range of tools, but that also allows us a more diverse set of workloads so we can attack more interesting, valuable use cases and deliver more value in that way. And then also, one of the key things that we're adding into the definition of a data lakehouse is the streaming. Historically, streaming use cases have been handled separately to the kind of pre-prepared batch data loads that we've had. One of the goals in the lakehouse is to load in that data, process it in real time, but also as we're going to store that data as it arrives into a format that we can analyze just like we analyze any other data. And so the idea there is that will reduce the barrier to using some of that stream data so that we don't have to have multiple pipelines for it, so we can do the analysis in real time that's valuable to do in real time, so things like your predictive maintenance, but also then we're creating a trusted, reliable copy of that data that we can use to take a historical view of, say, what's been happening in our factory over a longer period, or if we're, say, monitoring financial transactions that have happened over a long period, same thing. We want to be able to monitor those in real time and highlight if there's something that looks suspicious or looks dodgy, and do that in real time, but also have a log that goes back over a much longer period that will help us do the kind of deeper analysis and understand how our customers are behaving. What I've got on the screen is a great set of features. So I'm hoping the question on everyone's mind at this point is, can it actually work? Well, this is where I'm going to take you through Databricks' approach and showcase the unified analytics platform that they have, along with and together I think those really will bring the Lakehouse concept to life. So hopefully that sounds good. So this is the diagram that I'm going to build up, focusing on Databricks and the Unified Analytics platform and some of the components that they've built in. As we've already referenced, Databricks is built on the cloud data lake storage, so it provides an ideal platform for storing both structured and unstructured data. You can store any file in there. It scales to terabytes and even petabytes if you need. Databricks itself then is built on Apache, so that gives it great functionality for streaming real-time data. For the deep data science, we talked through some of the different packages that come built in with Spark there, and then there's Spark ML and big data approaches for that as well, and machine learning on structured and unstructured data. So all of those great things that we've got at the top of the screen there, we're getting out of the box with Spark, the analytics platform, and that optimized by Databricks. And so this really starts a bit like a data lake, or at least a data lake accompanied by tools optimized for key parts of our analysis. So nothing here new with the Data Lakehouse yet, but this is where we start to build in some of the extra components that help us add some of that structure, add some of the reliability within the platform. And that starts with the Databricks Delta Lake. And that fills in a critical layer of the modern lakehouse architecture. So it gives structure and reliability to data lakes in support of any downstream use case. And so Delta Lake gives you things like some of those reliable transactions, and it builds in a kind of structure. So alongside the data files, you're storing metadata files as well. So you know what columns are expected in the data set. You can set it up so that it's more flexible than that. If you've got data sets where the columns are going to be added over months, for example, you can make Delta Lake handle that. But equally, you can say, well, I want schema enforcement, and I want to make sure that the data is coming in within this rigid structure. Delta Lake will let you handle that. On top of that, you want a high-performance query engine, and another plug for Databricks here. The Delta engine is one that they've introduced relatively recently, and then it has Photon, which is another kind of technical enhancement to it. Both performance query engines that are built from scratch for Delta Lake, and they're fully compatible with Apache Spark. So you're taking all of the advantages that you have from using Spark as the platform, but Databricks have done a lot of optimization. It's got an improved query optimizer, vectorized execution engine. So anyone who's into those technical buzzwords, this has got the lot, basically. But no, more importantly, when you're using it, that makes Databricks a much faster platform than kind of vanilla Spark. So if you're looking to get your business results through quicker, processing large volumes of data and getting results into the hands of users, these engines will help you get the insights faster, get them into the hands of users, so that you can start making decisions based on those really complex analysis that's running on the data and giving really valuable insights. But it all happens at great speed, even on massive volumes of data. Bring this back. So in summary, we've got Delta Lake as the structured transaction layer on top of the data lake, and that allows you to overcome a lot of the challenges that we've historically seen through data lakes. So things like ACID transaction, indexing, fine-grained control, schema validation, and we can set up expectations of different data formats even, and if the data format doesn't match what's expected, you raise a warning or raise an error. Then on top of that, to ensure all of the analytics workloads can be executed very fast at scale, there's a low latency query engine built in the Delta engine. So it's going to be a great performance on top of the structured data sitting in the data lake. And then finally, all of that's brought together in a way that the data is actually made useful through things like the streaming analytics, the platform for data science and machine learning, the Databricks Unified Analytics platform, and more recently with SQL Analytics, building into the BI tool. So with that, I'm going to jump into the notebook and give a quick demo of some of the capabilities here. So if we switch over to Databricks here, you can see it's sitting in the browser. So Databricks is it's a web-based tool that we access using, in this case, it's Google Chrome, but it works in any of the major modern browsers. So within Databricks, we work in notebooks. So I'm going to go to a notebook that I prepared earlier and show you how we transform data and interact with data within Databricks. So in this case, we're looking at a finance data set. And one of the things that I'm doing here is bringing together data from 3 different regions. that are stored in the data lake in different files in slightly different formats. But one of the things that I want to do is bring those together into one common format here. And so by doing that in Databricks, one of the advantages I get with this notebook format is that I can write a commentary around what I'm doing. So you can see here I've said what I'm doing. I'm loading finance data, creating helper functions, and then the code itself is in a mix of languages. So I'm using Python here for most of it, and that gives me a lot of flexibility. So as I said, the 3 different regions have their data stored in slightly different formats, and I can use Python to manipulate that and get them into the same format. And you can see as I'm doing that, that I'm putting the data into tables, and I can see the data that I'm working with in the format that that's in. And it's really helpful as I'm going through and building up the code to be able to see exactly what I'm working with. And I said most of this is in Python. I've also got some SQL script in here, if I can find it. So in this case, what I'm using the SQL for is just to bring those 3 different tables together in the same format. I'll bring all those 3 different regions together. So using a fairly simple SQL query here, just unioning all between 3 tables. And that's something that it can be much easier to do using SQL rather than using the Python functions to do it. So you can choose which language to use based on when it is. For the different tables at the minute, I'm looking at them in table format. But as I go through the analysis to do it, I can also build up visualizations. So if I switch to this Explore data view, here's a SQL query that I've run earlier. And you can see in this case, I've just pulled out the fiscal week. So what week are we in? The value. So in this case, we're filtered to gross sales value. So we're looking at what the gross sales are and for a particular product. So this is a consumer goods data set. So we're looking at a particular product in here. I can see that in table form. If I want to switch to a chart view, just click here, switch to chart view. I can also go to plot and change more of the choices that I have here. So for display type, I might want to go to a line chart and see that trend as well. I can hit apply, and it will show me what that trend has been over time. So you can see very quick and easy to interact with, and something that you can use to just see what's happening in the data with very little effort and very little fuss. So the one other thing to point out here, I'm storing this in Databricks' Delta format, and that's done when I'm creating the tables. I save it just as a Delta format. So if anyone's used to Spark or what have you, there are different formats you can save in. So if you're saving a Parquet before, you just switch out Parquet and put Delta in. That's the only change to use Delta. And then we can create these tables using Delta, and those will be reflected. So then when I'm exploring the data here, this is bringing the data out of my, and that Delta table is also saved back in the data lake as well. So with that, let's switch back and talk a little bit about the Delta format and some of the advantages that gives us. So Delta Lake is a data storage layer. Key fact really, the data itself is stored as version files in Parquet format. So if you're familiar with data lakes, Parquet is a really common format to use. It's well compressed, so it stores the data pretty small, which saves you costs, but it's also it's stored in a way that's optimized for analytics. So for example, each column is stored separately. So if you're only using 2 columns from the data set, it can load it very quickly. And that choice means that it can be used in the fact that it's Parquet means it can be used across a wide range of tools, even if they don't understand Delta, the Delta format. What the Delta format adds on top of that is the Delta log, which then means you can do things like viewing the changes in the data over time. It keeps track of things like the metadata, so what columns are expected in the data set, what type are those columns, and so on. So it gives you greater reliability and performance in your data lake. And then for anyone who wants to see a list of the key features, kind of technical aspects of this here, but there are some great features that are offered by Delta Lake that make it a great match for kind of structured data within a data lake. The next thing to show you is SQL Analytics, and this is where I was talking about a kind of more BI focused tool that's been released more recently by Databricks. When it was in the second half of last year. So it's a new SQL user experience that complements the notebooks. So the notebooks aren't going away, but this is added on. So if you're used to writing SQL queries, if you're used to building up dashboards that you can go back to again and again, That's what SQL Analytics is great at, and that's where it comes into play. Also, you can build up connections and queries in SQL Analytics and then connect your favorite visualization tool. So even things like Tableau, Power BI, Click, all of those great tools can be connected using a SQL interface that can go straight into the SQL Analytics tool. If I try and show you very quickly what this analytics interface looks like, just so that you've seen a dashboard at least, we switch to that from here. So you build up your queries, you write your queries as SQL queries. You can build the visualization, so on the same data set, edit my source. So you see I've built this SQL query, so it's doing a few joins to get the bits from the different tables. And then down here, I can either display it as a table, or I can build up charts. And if I wanted to edit that visualization, you can see it's just a series of drop downs here. What goes on the X, what goes on the Y axis, what am I grouping by, and what do we do with the different components. It's a very, very simple, intuitive interface, kind of point and click approach. And then from that, once you've got a series of visualizations built on one or more queries, you can build that up into a more complex dashboard that you can set to refresh on a schedule. You can come in and refresh it manually as well. And if you want, you can even have things like alerts. So if a figure goes over a certain amount, send out an email to everyone and let them know what's happened. So there's an alert option there as well. So all those great things that you expect from BI tools is available immediately in Databricks based on the same data set in the same platform. Or if you want to connect to tools you're already using in, this gives great connection into the existing tools as well. Just a final couple of comments, and then I'll get to any questions or ask. Just a reminder, but to talk through the different platforms. So I mentioned that this is available on Azure and AWS. It sits very neatly within the platform. If you're storing the files in Delta, those can then be passed into Synapse. So if there are scenarios where you want to be using an actual data warehouse capability in there, or you want to be storing subsets of the data into a SQL DB, or you want to go straight to the end game and point whatever visualization tool in front of it, you can do all of that within the Azure platforms. Databricks have made everything that they're doing very open, so the data that you write in, you can always get out in a great format. Same with AWS. So different set of tools. You can see some of the images in the slide change, but really not very much. Databricks, again, the data is available in an open format that can then be passed into Redshift or RDS. Both of these are integrated very tightly with the security in the platform. So whether you're in Azure or AWS, it will leverage the role-based security provided by the platform. Exciting new news. This is a blog post from last week. So Databricks have announced the launch of Databricks on Google Cloud. If you scour the web, you can find conversations between the CEOs of both platforms. At this stage, it's private preview and only available in North America, I believe. So if you're either in that part of the world or happy to put your data there, do get in touch. We can look at the private preview as an option. In the world, though, worth being aware that that's something that's been announced recently. But for the minute, Azure and AWS are the platforms that are available in general availability. So those are probably the ones to look at for the meantime. But it's if you're wedded to Google Cloud or keen on that platform, worth being aware that that's a recent announcement as well. So how can you get started on this? With a number of customers, we've been helping move to the cloud and moving to Databricks and tools. We've built this series of steps to call it the path to the modern data platform. And where we like to start is with an initiation workshop. So we can tailor that to the specific starting point in the journey that you're in. So if you already know all the tools, you know exactly what you want to do, that's maybe a shorter session, looking at the use cases, what's most valuable, what can we help with most quickly to deliver value. If you're new to the tools, though, we can stretch that out, do an introduction to the tools, an introduction to the advantages of them. And so the initiation workshop is a great way to get started. And in the past, with some of the on-premise data solutions, it was really important to spend a good chunk of time at the start figuring out whether it's the 3-year, the 5-year data strategy, and figuring out all the use cases within that. Now I would say it's definitely the case that you get started quickly. You You can be more flexible as you go along. It's good to have some idea of where you want to go with it. And certainly that's where the initiation workshop, proof of value comes in. And then you start to build your strategy. But you can get started without having to know exactly where you're going to end up. And that allows you to be faster, to innovate, and to be flexible and adjust as you go along as well. So thinking about, if we were to make that, say, a 2-day workshop, we just put an example of the sections that we put in that initiation workshop here. So starting with a half-day technology overview, half-day hands-on introduction, it can be really good just to see exactly how it works and how it can help. And then 1-2 days of taking a couple of business use cases. You provide the data, we provide the experts. We'll spend a couple of days and in small teams get hands-on and showcase what we can do. And that typically then is what we'll use to scope out what the first proof of value will be, and how you can get started with delivering some of this stuff. So if that approach sounds interesting to you, drop me an email. My email address is on the screen, and we'll send out the slides after this session as well, so you can pick that up from there. Finally, I wanted to show an example of what this can look like for a customer. So again, this is based on things that we've done at other customers, and how you can deliver value along the way. So in this case, we've broken down the journey into kind of 5 steps, starting by making the data available in a single platform, then moving on to structuring the data so that the analysis is quicker and easier, then standardizing KPIs. From there, you can start to build out kind of targeted solutions, and then finally bringing, in this case, it was a finance data lake, so bringing finance data alongside other organizational data. We have got a whole webcast that's around this. We're working on getting the recording out, so I can't give you the link for it yet, but if this is of interest, let me know, drop me an email, and we'll make sure to get you the recording of that session. So yeah, thank you for attending today's session, and we'll end there.